Section 9.1.17, we want to construct a 90% confidence interval of the population proportion using the given information, where x is equal to 121 and n is equal to 220. So this is the characteristic and this is the sample size. So the first thing we want to do is we want to be able to find the point estimate. And so the point estimate is taking the value of x and then dividing it by n. So if we take 121 and then divide that by 220, then we get the following. We get 0.55. So therefore, the point estimate is equal to 0.55. Okay, and then what we need to do is then now we need to use the point estimate to confirm that the confidence interval can be found. So recall that n times the point estimate times 1 minus the point estimate must be greater than or equal to 10. So we know that n is 220. We know the point estimate is 0.55. And then we're going to take 1 and subtract 0.55. We're going to multiply those together to see if it's greater than or equal to 10. Well, we get 54.45. And so therefore, that is greater than or equal to 10. And so now that we can confirm that, since 54.45 is greater than 10, we can now proceed in constructing the confidence interval. So, in order to construct this, we first need to find our information that we need to be able to construct this. Okay, so we have two formulas. And so let's recall what those two formulas are. We have our lower bound and then we have our upper bound. Okay, so we know that the point estimate is equal to 0.55 that we need. Okay, and we also know that the value of n is equal to 220. Okay, now what we want to do is we want to find z alpha divided by 2. So let's go ahead and do that over here. So over here, we'll just call this step 4. Okay, we know that it's a 90% confidence interval. Okay, so we know that we need to take 100% and we need to subtract 90% to get 10%. And so therefore, that's going to give us 0.10 for alpha. So alpha is going to represent that. So if we have z alpha divided by 2, we know that that's now z, which is 0.10 divided by 2, which becomes z of the area to the right of 0.05. So what we want to do is we want to find the z-score, or the critical value, of when we have the area here. So the area here is 0.05. We want to find out what is that z-score. And so we're looking for the area to the left here. So the area to the left is 1 minus 0.05, which becomes 0.95. Okay, so we can either use StatCrunch, or we can use the table, or we can use the calculator. So I'm going to use the calculator first, which is INV norm. We know that our area to the left is going to be 0.95. We know that our mean is 0 and our standard deviation is 1. So let's go ahead and use our calculator to determine that. So we have INV norm. We're going to go down to INV norm. We're going to put in 0.95. We know that our mean is 0. We know that our standard deviation is 1. And then let's go ahead and enter. And therefore, we're going to get the following critical value. Okay, so if we round that to 3 decimal places, that gives us 1.645. So over here, we can let that equal 1.645. Okay, now we could also do this on StatCrunch if we wanted to. So just let's go ahead and just determine this here. We know our mean is 0, our standard deviation is 1, and then we're going to put in the area of 0.95. And you can see here, it's also going to give us that critical value that we need, which is 1.645 rounded to 3 decimal places. ahead and do that again. Okay, so while that's loading up, now we know that we can either use StatCrunch or the calculator, or we can use the table of values to be able to determine the critical value. Now let's go ahead and find the lower bound and the upper bound. Okay, so we're going to abbreviate this as the lower bound. Okay, and that's going to equal the point estimate, which is 0.55 minus the critical value of 1.645 times the square root of the point estimate, 0.55, times 1 minus the point estimate, divided by the sample size, which is 220. And let's just put the formula in for the upper bound. So the upper bound is going to be, again, 0.55. And you know what we can do here? We have 0.55 plus 1.645 times the square root of 0.55 times 1 minus 0.55 over 220. Okay, so let's go ahead and use our calculator. So if we want to use our calculator here, we're going to put in what's inside the radical first. We're going to take 0.55 and we're going to multiply that by 1 minus 0.55 and then hit enter. And then we can divide by 220. Okay, now we got the number inside. We're going to take the square root of that. So we're going to take the second square root, and then we have an answer key, which is the previous answer. So second answer, and then hit enter, and then we're going to multiply it by minus 1.645. So that's negative. So we're going to have multiply, or second answer, times negative 1.645. And then we're going to add the 0.55. And so therefore, here we get our results. So we're going to go ahead and copy that and round it to 3 decimal places. So therefore, we get a lower bound value rounded to 3 decimal places to be 0.495. Okay, and then we're also going to do the upper bound. So if we do the upper bound, again, we're going to take 0.55 and then multiply that by 1 minus 0.55 and then divide that by 220. And then we're going to take the square root of that. So we're going to take the second square root time of the answer. And then we're going to multiply that by 1.645. And then we're going to add 0.55. And so therefore, there is our calculation there. So let's copy that. So if we round it to 3 decimal places, we will see that we get 0.605 for the upper bound. So the upper bound is going to be 0.605. And so if we write this in interval notation, we can say that the first, we have parentheses, the lower bound is 0.495, and then the upper bound is 0.605. And so here we can say that, so summarizing this, we know it's a 90% confidence interval. And so we can say that one can be 90% confident that the proportion is between 0.495 and 0.605.